Hey guys, what's going on here?
He's been out running in the 30-degree sun, hasn't had too many fluids, and he started stumbling around, so he thought we'd call him.
Yeah, good call. By the looks of it, he may have heat stroke. So how long was he exposed to the sun for?
A good couple of hours. Yeah, as I said, he hasn't had too many fluids either.
Yeah, right. Well, let me take his temperature and see. Oh yeah, it's quite warm. Have you had any nauseous tendencies in the last 15 to 30 minutes?
I feel quite nauseous, during running especially. Yes.
By the looks of it, your body's overheated due to the combination of prolonged exposure to the hot temperature, strenuous activity and excessive dehydration. You have a high body temperature of over 40 degrees Celsius. You also present signs of slurred speech, confusion and also feel nauseous, all symptoms of heat stroke. Your rapid breathing, red skin, not to mention your heart rate and throbbing head are all signs of this condition. So the heat stroke has had an effect on 3 different organ systems. These organ systems are the muscular system, the cardiovascular system and also the intracommentary system. Today, 3 of us are going to talk to you about the interrelationship between 3 organ systems and how it affects heat stroke as well.
Yep, so because of muscle flexion and contraction, your body produces heat as a byproduct, which ultimately affects your thermal homeostasis because you cannot remove heat from your body as quickly as it's being generated. And because of this, your muscle movement is likely to be stiff and tense, which limits capability, which can ultimately result in heart failure, which is why we take things like this. So ultimately, your thermal homeostasis strains all your major organ systems because the blood and gas exchange is ultimately far slower and under a lot more strain than it usually is. So obviously, because of this, it causes things like breathing difficulties, which you've had, coughing, you're throwing up in the worst case, and obviously when you came in, you were close to collapsing, and after that, it can lead to heart failure or heart attack.
So the muscular system also relates to the intracommentary system. The body has heat and cold receptors located in the skin, so when the body temperature rises, the hypothalamus sends a nerve signal to sweat-producing glands, causing them to release about 1 to 2 litres of water per hour, cooling the body. However, a few patients was exercising at a rate where the body could not release the 5 litres of water per hour, resulting in exhaustion and heat stroke.
So that explains how the intercommentary system could prevent heat stroke. But how does the intercommentary system prevent dehydration?
Yeah, so that's exactly right. So basically the intracommentary system consists of skin, hair, nails, glands and nerves. The skin is waterproof and protects the body from dehydration because its outer layer contains a protein called keratin and glycolipids. The outer layer is named epidermis and consists of 20 to 40 rows of stacked cells called keratinocytes. The way it protects the body from dehydration is through the keratinocytes. When they move slowly towards the surface, which break the nuclei down and the cell membranes are gradually replaced by keratin and glycolipids. Due to the keratin and glycolipids being hydrophobic, the layer of the skin is waterproof. Therefore, the waterproof layer prevents dehydration because water is unable to leave the body by passing through the skin. However, excessive dehydration could result in eventual death, so fluids must flow through the body to do it. Also, the skin's immense blood supply helps regulate temperature as the dilated vessels held for heat loss while restricted vessels maintain the heat. Therefore, the skin regulates body temperature with blood supply.
And the respiratory system involves the muscle pumping blood in order to transfer inhaled oxygen throughout the arteries and veins of the body. The exhaled carbon dioxide goes between the capillaries and muscle surfaces whilst removing byproducts, and this supports physical exercise and running long distance like you were trying to. Also, the circulatory system maintains the blood supply throughout the body and is the transportation system for oxygen and carbon dioxide between the lungs and the muscle tissues. Dilation and constriction occurs from the lungs' ability to regulate oxygen and the carbon dioxide of the body. The pulmonary trunk of the heart transports the oxygenated blood to the tissues throughout the body via the pulmonary vein and arteries. We believe the sympathetic and parasympathetic effects may cause imbalances in your oxygen and carbon dioxide dilation and constriction, which causes coughing and laboured breathing.
Okay, makes sense. But you mentioned the muscular system. How does that relate to heat stroke?
So basically the muscular system allows the body to contract and flex all the groups and tissues. The skeletal muscle generates heat as a byproduct from the flexion and extension of the muscles, and then triggers thermal homeostasis.
So we've had to have a more insightful look into this. So therefore we've brought in the heart surgeon over here, Brenton, and he's going to come and chat to you today about the cardiovascular system and how that's affected your heat stroke.
Heat stroke also affects the cardiovascular system, as you know. A combination of intense whole-body exercises, such as your triathlon running, and ambient heat stress or dehydration-induced heat stroke induces effective cardiovascular strain, as demonstrated by a reduction in your heart rate, stroke volume, arterial pressure, and blood flow to your brain, skin, and exercising muscles, all of which occur as a result of exhaustion.
Okay, but how does that explain why I'm so stressed and confused?
Yes, this is explained by you develop psychological changes such as mental confusion or unconsciousness when the body's temperature rises to 105 degrees Fahrenheit or higher, which has occurred here today. Body proteins and the membranes that surround the cells in the body, especially in the brain, begin to become damaged or malfunction at these higher temperatures. The extreme heat can harm internal organs, causing muscle, cell, and blood vessels to break down. Internal organ injury and death. Luckily, in this instance, there will be no fatality to your health, but there's no certainty.
Alright, good everyone.
Howdy.
We're gathered here today to talk about previous health experiences and scenarios that we may have had that have led to injuries. A couple of us I know have had previous injuries, and I had a question straight away to Brody and Brenton, wondering about your previous injuries and when you went to the doctors, if they used appropriate use of anatomical terminology, and what did they say and what did you understand?
Brenton, you go.
Okay. Well, the doctor described the injury to me as the distal part of the tibial shaft being fractured in a crosswise pattern. He said the bone hadn't pierced any of my muscle or skin, so it was a closed fracture. At the time, I didn't understand the anatomical terms. And the information I did understand was that the tibial shaft was broken, and I understood that there was a bone in my leg that was broken. But afterwards, he did use appropriate language in layman's terms, so I could understand what actually happened to my leg and have a better understanding of the situation.
Yeah, with mine, since I was still pretty young when it happened, so he didn't really use any anatomical terms. The majority of what he said to me was it's structural damage to your shoulder from subluxing it, so it goes out and back in by itself. Yeah, he said there wasn't any damage to any surrounding structures. It was just the majority of the supporting structure of the shoulder that had troubles from the injury.
Yeah, fair enough. Did you have any questions, Reese?
Oh, excuse me. Sorry, no, I don't have much to go off that, but I do have another question for both of you too. And then this one will come to Felix and myself as well. How significant was your doctor's appointment in developing an insight into your understanding of anatomical terminology?
I'd say the doctor's appointment was quite intuitive and detrimental to my understanding of what a broken tibia actually was in my case, because I had little to no in-depth knowledge of what a broken tibia actually entailed, apart from the bone itself actually being broken. And knowing that I would be sidelined from sport for a couple of months, I had no baseline understanding of anatomy or anatomical terms at the time. So, I have a vivid memory. The doctor explained in both layman's terms and anatomical terms, so I could have the best understanding of my injury. And I remember the origin and location of my injury that was explained anatomically, which was the distal part of the tibial shaft was fractured, and I would require 2 screws in my ankle to hold the muscle ligaments and tendons in place. So,
yeah, mine was mostly in layman's terms about, how I won't be able to play sport, obviously, and then the majority of the anatomical stuff was mainly movements I couldn't do. So, like, obviously rotating of my shoulder, any contraction, any flexion, they told me it was going to be pretty painful for a little bit of time because of it, but that's about it.
Right. I think we might just move on from here. Sorry, Felix. So we'll move to the role play part of this now. So through our role play, obviously, pretty proud of what we've done. Did that also help in developing any knowledge or insight into anatomical terminology? Like, did you learn anything from it?
Well, I think it's important that what I've taken from this is you have to adapt the language and the terms you use with different audiences. So, like, if you're talking to a bunch of doctors or a bunch of physios, it's appropriate to use anatomical terms to be very specific so you can describe an injury to them and they can have an understanding of it. But if you're talking to your mum, your brother, or your sister who have no idea about anatomy at all, it's not appropriate to use anatomical terms. You have to use layman's terms so they can understand.
Yeah.
Yeah. I think we should all be pretty similar to that one.
Awesome. Yeah. Well, thanks very much, guys, for that insight. It was very interesting, and you've given me a deep insight into anatomical terminology and the difference between that and lay terms for injuries and doctors' explanations.